And this problem relates to apples from a grower's crop which were normally distributed with a mean of 173 grams. And this is designated with a letter mu, and that is, we'll say that's 173 grams, with a standard deviation of 34 grams. This is all the information that we need to draw a normal distribution curve. And as I mentioned, our mean is 173, which goes straight under the mu over here for 173. And our standard deviation, which is this part over here, is 34. And I assume you know what standard deviation means. It means virtually that it's how much the data is spread around the mean, or how far the data is spread around the mean. So if the mean of our apples is 173 grams, the first standard deviation will have a value of 207 grams. So that really means that about 34% of apples will be between 173 grams and 207 grams. And if I add another 34 to this, I'll get 241, and then further on 275. On the left-hand side of the mean, I'll just take away 34. And this tells us that almost all of the apples weigh between 71 grams here to the mean of 173 and to the maximum weight of 275 grams. Now notice that we are told also that the apples weighing less than 130 grams were too small to eat. In a scale like this, the 130 grams will be somewhere between here and here, between the -1 deviation and -2 deviation, and it's hard to tell exactly where I'm going to put it. But approximately I can see that the apples here in the yellow section are going to be too small to sell. And our question is, what percentage of the apples from this crop were too small to sell? And this can be easily calculated using a calculator such as Casio. Our X distribution must be normal with a cumulative distribution with boundaries from the lower to the upper, with a value of mean and a value of the standard deviation. These values will be, in our case, the normal CD. Our lower part is a negative infinity, as we are starting from the left-hand side over here, and it starts from the negative side, followed by 130, followed by the mean, which we're told is 173, and also the standard deviation of 34. Using statistics in the menu, press norm, followed by NCD, making sure that the data is variable. Substitute the above values into the calculator. For negative infinity, you might want to put a very large negative number such as 10 to the 99, minus 10 to the 99. And you should obtain a value for the probability of X being less than or equal to 130, being 10.3%. And given this probability of 10.3% being too small to sell, we've got another question. What is the probability in a picker's basket of 100 apples that more than 10 apples were too small to sell? What this means is that you're going to go through 100 apples in a picker's basket and you're going to put them aside. Are they too small? Are they under 130 or over? So it's one or the other. It means success or failure. And when you hear the word success and failure, you automatically start to think about binomial distribution. In this case, you are looking at the probability of it being too small as success. And this problem is also easily done on the calculator in the statistics mode, where X this time is distributed binomially. And the distribution will be cumulative, and that is because you're looking for more than 10 apples that were too small. You might be wanting 11 or 12 or 13, up to 100. So you will have boundaries, the lower boundary and an upper boundary. You also need to know the number of trials you're going to take, and then you need to know the probability of that success. And so the numbers that you'll be putting into your calculator for binomial cumulative distribution, the lower part here is very critical, because remember, you want more than 10 apples. You don't want 10, you want more than 10. So our lower boundary is going to be 11. The upper boundary is going to be up to 100. And we also have 100 trials, because we're looking at 100 apples. And the probability of that success of being too small is going to be 0.103. And these are the numbers you want to put into your calculator. And this time, after the statistics into the distribution, you will need to enter binomial, followed by binomial cumulative distribution. And so the probability of getting x, which is greater than 10, we could say the probability of x being greater or equal to 11 is equal to, using the calculator, of 0.0456. And of course, up to 3 significant figures, and because it's a probability, it must be less than 1, not percentages. And so if you found this particular information useful and helpful, then please subscribe to my channel, and I'll see you in the next video.